learned about SOHCAHTOA. So cosine of an angle is equal to the adjacent over hypotenuse. And sine of an angle is equal to opposite over hypotenuse. And sometimes, now that we learn the unit circle, we can use the unit circle to evaluate. We don't have to draw a triangle every single time. But that doesn't go away. Cosine is still adjacent over hypotenuse, sine is still opposite. We still need those because we don't always have increments of 30 degrees or increments of 45 degrees on an angle. Sometimes it's 20 degrees. And if it's a 20-degree angle or an angle we don't know, we need to use our SOHCAHTOA. We're focusing now just on sine and cosine, just like the title says, sine and cosine. We'll get to the tangent and then the other three reciprocals, secant, cosecant, and cotangent also. But for right now, we're just worried about cosine and sine. So the other day we told you cosine was the x and sine is the y. So if we think about this unit circle right here, there's a triangle. We put the triangle down that first day on our unit circles, and we got an x and a y value. And we had this radius right here. That's the radius of the circle. No matter where that triangle was, you have a radius that goes from the center out to the edge. So if we use adjacent over hypotenuse of the angle, so what angle do we use? Well, this is called a reference angle right here, which we'll get more into reference angles in a couple days. But that angle right there is always going to be, we're always going to reference or talk about the angle that's attached to the x-axis when we're dealing with the unit circle. You can do other angles, but then it's just a right triangle, and you have to do your 30, 60, 90, or 45, 45, 90 from there. So this is the angle we're talking about. So if we want to take the adjacent of that angle, x, over the hypotenuse is r, we can say that's x over r. Because this is the unit circle, we learned that the radius is 1, which is x over 1, which is y. The cosine of an angle is equal to the x value. That is only when we're on the unit circle. If we are not on the unit circle, the radius is not 1, none of that applies. Only for the unit circle. And it just allows us to evaluate and find values a lot quicker than drawing a triangle every single time. We do the same thing for the sine. This angle, opposite, y over hypotenuse r, y over r, because we're on the unit circle, r is equal to 1. So that's why we can say the sine of theta is equal to y. The reason we're leaving tangent out for right now, because tangent deals with the x and the y. So we've got to do the ratio of y over x. And then the reciprocals are, you flip them all. So right now, all we care about are the x and the y values and on the unit circle. So these examples, evaluate. Same evaluate that we did the other day. But if we look at all these, 7 pi over 2, 540, 810, negative pi over 4, none of those are on our list of the unit circle. They're all too big or too small. So we learned about coterminal angles. Now, there were a few of these on that first homework. Some of you figured it out, some of you asked, some of you just wrote the answer down, you got it wrong, you don't know. But now that we know coterminal angles, we can figure out what the sine of 7 pi over 2 is using our unit circle. And we can do that a couple different ways. One way is find something that's coterminal to 7 pi over 2 that does lie on the unit circle. So 7 pi over 2, 2 goes into 7 3 something times. So it's too big. So if I take 7 pi over 2 and I subtract 2 pi, 4 divided by 2 is 2. I need a common denominator. I get 3 pi over 2. Now, 7 pi over 2 does not equal 3 pi over 2. But the sine of 7 pi over 2 does equal the sine of 3 pi over 2 because they're in the same place. Right down here. This is where they are. On our unit circle, that point is labeled 0, negative 1. So we want to find the y value. So our answer would be negative 1. Now, another way that we learned about the unit circle is that it is broken up in fourths or in sixths. Remember, this is 0 to pi. So for one part of it, 0 to 1, this was 1/4, 2/4, 3/4, 4. 5/4, 6/4, 7/4, 8. If we just kept counting, this is 9/4, 10, 11, 12, 13, 14/4. 7 pi over 2 is the same as 14 pi over 4. We just need a denominator of 4. Now, could we change that to 6's also? Yes, we could have changed it to 6's. So you can make, if you can make your denominator a 4 or a 6, then you can just count your sections on the unit circle and get to that answer also. However you want to do it. It's up to you. You want to count by 4's or 6's? And again, what I mean by 6's is we broke our unit circle up like this also, 30, 60, 90, 120, 150. 1 6, 2 6, 3, 4, 5, 6, 6. Then we had 7, 8, 9, 10, 11, 12. This one, 2 could have turned into a 6. 21 pi over 6, and you counted 21. Once you got to 21, then that's where you end up. So however you want to do it, both ways work. It is completely up to you how you want to figure out what that answer is. So if you're taking the sine or cosine of something that's not on the unit circle, find what angle is coterminal to it. Cosine of 540. 540 is too big. 360 is the biggest number on a unit circle. So what I would do is I'd take 540 and subtract 360, and you get 180. So what that means is, if I start at 0 and I go to 180, that's where I am. But if I add another 360, then I'm at 540. You can keep adding and subtracting forever. Don't have to show any work. Okay? These do not require any work. Very good question. Okay, that's a lot of work that's not necessary. Especially if you came from Algebra 2 for AP. You probably know what these are. This is like the easiest thing ever. You can just write it down. Or even if you didn't and it makes sense to you, you can write it down. All of this explanation is just if you don't know where that came from. Then you might need to do a little work. If it is easy and you can just write -1, that is fine. These problems require no work. I will always, always tell you what requires work and show you what I expect. But all of these today require nothing. Anything else so far? Okay. So 540 and 180 are at the same place. That's over here in our unit circle. That's -1, 0. We want to know the cosine, which is the x value, -1. Now, also realize that it doesn't say write your answer in degrees or radians. I think a few people are getting confused, and not necessarily this class, but okay, well, it doesn't say if you want your answer in degrees or radians. Okay, your answer isn't going to be a degree or radian. It's just going to be a value. The degree or radian is always going to be what is attached to the cosine or the sine. The cosine of an angle, the sine of an angle, it doesn't matter if that's degrees or radians. You're just finding the value of it. It doesn't matter if you're finding the value. Sine of 270, sine of -90, those would all be the exact same number. Okay, so that's why these don't say degrees or radians, because your answer is just a value. This one hopefully should be one of the easier ones on here, because we talked the other day. This is 0, this is pi, we're at 2 pi, 3 pi, 4 pi, 5 pi, but we can also go the other direction. So if I'm going in a negative direction, this is -1 pi, so this could be plus or minus, -2 pi plus or minus, -3 pi, -4 pi. That only works with the zeros and the pi's right there, the integers. We can't do that same thing anywhere else, where the even integers are over here and the odd integers are over here. Whether it's plus or minus, it doesn't matter. So -4 pi is going to end up right here. Well, this point on our unit circle is the point 1, 0. Sine is the y value, so your answer is 0. 810. 810 is way bigger. 810 is 2 times, at least over 2 times too big. So instead of subtracting 360 and subtracting 360, minus 360 minus 360 is the same as minus 720. I'm just going to go ahead and do 2 rotations at once. When I do that, I get 90 degrees. So again, I look at my unit circle. That's right here. Here's 90 degrees. And it is what? 0. If it said sine of 810, It'd be 1. Looking for either the x or the y value. All right, so this next little table on your notes has a little x and y axis and has these letters A, S, T, C. If you like acronyms, this acronym stands for All Scots Take Calculus. Starts in quadrant 1, quadrant 2, goes in order 1 through 4. Now, I'm going to show you what I think is a little bit easier or something you don't have to think about so much. This chart tells you just where all of the trig values are positive. It tells you that all trig values are positive, sine is positive, tangent is positive, which we're not dealing with yet, but we will, and cosine is positive. All are positive, so sine is going to be positive up here, all in sine. Cosine is going to be positive over here, all in cosine. Tangent is going to be positive here and here, all 3, or actually all 6, and then tangent. Now, I'll go back to this page in a second, but if we look at this, if I just gave you an x and y axis and you plotted points, all of you could plot points whether the x's were positive or negative, right? In quadrant 1, x's are negative, cosine, y's are negative, sine. In quadrant 2, any point you have, or look on your unit circle, all of those points on your unit circle are negative and then positive, negative and then positive, negative and then positive. So if your angle ends up in quadrant 2, so if it's anywhere between 90 and 180, or pi over 2 and pi, then if it asks for the cosine, we know it's going to be negative something. The sine is going to be positive something. Down here, if it's between 180 and 270, everything's negative down here, x's and y's. And then between 270 to 360, yep. So when we get to tangent, the reason tangent's positive down here is because it's sine over cosine, and sine divided by cosine, 2 negatives, when you divide them, make a positive. That is absolutely why. Okay? And then down here in quadrant 4, your x's are positive and y's are negative. So, I mean, why is that? Because this is the line x equals 0. Positive 0 goes this, or positive x goes this way, negative x goes that way. X's are negative, x's are positive. This is the line y equals 0. Y is positive as we go above 0. Y is negative when we go below 0. So I think of positive and negative just by what the quadrant is. Is x or y positive or negative in the quadrants? If you like acronyms and this is easier for you, again, this tells you where it's positive. There's going to be 2 quadrants where it's positive and 2 where it's negative, always. There's no exception. 2 are positive and 2 are negative, always. So this is just an acronym to help you tell you where they're all positive. So if they're not positive, so sine is positive here, that means it's negative here. Cosine's positive here, so it's negative here. Tangent is positive 1 and 3, so it's negative in 2 and 4. And that's because the x's and the y's have opposite signs in 2 and 4, again, when we get to tangent. All right, so this next one just says, state, oh, I don't know, what does it say? Is the expression positive, negative, or 0? So those are your 3 answers. Don't tell me that it's -1, that's not an option. Is it positive? You can use abbreviations. Negative, is it 0? You can use P, N, Z. I don't care what you write. You can abbreviate. Positive, negative, you can write the word 0. I don't care how you say that. Just don't tell me that the answer is negative √3/2. That doesn't answer the question. You have 3 options. So same thing we just did. We have to figure out where 3 pi is on our unit circle. So here's right over here, because this is 1 pi, 2 pi, 3 pi. There it is. Because we're looking for the cosine, yes. So that's not in a quadrant. So if it's not in a quadrant, we have to be sure to know what it is on the quadrantals. They're kind of like special cases, kind of like no solution, all real numbers, infinitely many. Quadrantals are a little bit special. On a quadrantal, our answer would be negative. 2 pi over 3 is in a quadrant. It's in quadrant 2. So if we look at our unit circle, here's 2 pi over 3. We're in quadrant 2. We're looking for the y value. Quadrant 2, the y value is positive. If that had said cosine of 2 pi over 3, cosine is negative in quadrant 2 because x's are negative in quadrant 2. Cosine of negative pi over 2. Now, negative pi over 2 is not something that's listed on your unit circle. So, we could add 2 pi, or we can just think of this as negative. Negative tells us what direction to go. Pi over 2 tells us how far to go. So if I'm at 0 and I go in a negative direction, where am I going to end up? Right here at 270, at 3 pi over 2, whatever, however you want to think of that. It doesn't matter if you change that to degrees, radians, because your answer is just a number, or a positive, negative, or 0 in this case. So that's 0, negative 1 down there. So the cosine is 0. So that one, I mean, whether you write 0, you write z, I don't care how you show that. That one's a little tricky because evaluating or telling you 0, 0, that's the number that represents the word 0, so it would be the same. Negative pi over 2. Pi over 2 would be up here.
Because it's the opposite from the 90. Okay. Because I was looking at 3 pi over 2. That's why I was confused.
And that's the same place. Negative pi over 2 is coterminal to 3 pi over 2. Because if we do what we did a second ago, where we took negative pi over 2 and we added 2 pi, which would be 4 pi over 2, that equals 3 pi over 2. So finding the cosine of negative pi over 2 is exactly the same as finding the cosine of 3 pi over 2. Negative pi over 2 and 3 pi over 2 aren't equal, but they're coterminal. But the cosine of each one of them is equal, because the cosine is doing something to it. And then cosine of 45 degrees is in quadrant 1. Everything's positive in quadrant 1. Positive. Could we find the value? We could, but it doesn't ask that. Be sure you follow the directions.
For 6, could we just apply the same thing that I was talking about earlier?
Mm-hmm. Yep, absolutely. Because again, these, I wouldn't require you to show any work. So how you get to that answer is completely up to you. Now, there are some where we need to show a little bit of work. So don't ever hesitate to ask, I did it this way, does this work? Because a lot of times it does, or maybe I didn't think of it that way or didn't show it that way. Sometimes there's special circumstances where it does or doesn't work. So please do not hesitate to ask if it works a certain way. These work a ton of different ways depending on how you see it, especially if you're familiar with the unit circle and how to get everywhere. All right, these last ones, name each quadrant described. So it's going to be, our answers are going to be quadrant 1, 2, 3, or 4. We know that.
Quadrant 1.
Let's see, quadrant 1, is that the correct answer? Okay, how did he get quadrant 1? Like, how does he even know that? Well, greater than 0 means what? Positive. So y's are positive. Y's are positive in 1 and 2. This is x's are positive. X's are positive in 1 and 4. So, absolutely correct. Quadrant 1 is the answer. You will always only have one answer. Now, that doesn't mean that there could be no answers. There could be problems out there. We're not going to give you problems where if we ask you which quadrant, that there's going to be one answer. There will never be multiple answers. Never ever will you have 2 answers in a problem like this. Not that there can't be, we just aren't going to give you any like that. A little bit different on this one. Now we already know this one is either 1 or 2. So all we have to do over here is check 1 and 2. Doesn't even matter what happens in 3 and 4. Well, let's see who's right. So what we're doing is we got to pick an angle in quadrant 1 to see if the angle we picked makes it true. Pick an angle in quadrant 2, see which one makes it true. So if I pick, let's say I pick 10 degrees, that's for quadrant 1. Quadrant 2, I pick 100 degrees. So whichever one I picked is going to be true. We don't even care about 3 and 4. We know it has to be 1 or 2. So sine of negative 80. Here's 0. Negative 80 comes down here. Is sine positive down here? So that means when I pick 10, it did not work. Say that again. I just rewrote this. I just plugged in a number. So 10 minus 90. So it's just from this. So
saying like through, like, okay, never mind. That's a subtraction.
oh, yes, minus.
So you just plugged in a number from quadrant 1?
From quadrant 1. Any number. So I want to know, does quadrant 1 work? So I pick anything between 0 and 90. Don't pick 0, don't pick 90. Between 0 and 90. So 1 degree or 90.1, whatever. 1 to 89. Pick 1 to 89. See if it works. If it works, terrific. If it doesn't, check the other one. The other one's going to work. Okay, but just make sure you didn't make a mistake. 100 minus 90. So that's the sine of 10 degrees. Is the sine of 10 degrees positive? Yes, because that's in quadrant 1. So that one works. So this answer would be quadrant 2. So find the one that's easier, see what 2 quadrant makes it true, and then all you have to do is check those 2 in the other one and see which one's true and which one's false. Now, if you get a bunch of falses, then go back and check because you did something wrong. There will always be an answer. There's no such thing as no solution on a problem like this. There's no such thing as multiple answers, all the quadrants. Okay, it'll always be one solution.